Okay, so we're good to go. Sound good? Okay, everyone can hear me? We've got a nice small room, so that's nice. Hopefully everybody at home can hear as well. All right. Well, welcome everybody. This is actually my first time in New York, so this is real exciting for me. How many of you guys have been to droidCon New York City before? Okay, good number. Very nice. Cool. So my name's Ryan Harter. I'm an Android developer. I'm a Google developer expert for Android. I'm based out of Chicago. And I work for a company called Pixite. We make creative apps, do a lot of OpenGL, that type of stuff. That's not what I'm going to talk about today. Today I'm going to talk about eliminating boilerplate in Java. So if we're all Java developers here, then we probably know that Java has boilerplate, right? That's pretty common knowledge. We can admit that. A lot of people would argue that Java is boilerplate, which is also kind of true. There's just a lot of boilerplate, a lot of stuff that you have to do in Java that like we write computer programs, right? They should be able to do this for us. So as an example of this, here's a pretty simple user class. This is a simple model class, username, first name, last name, and age. And then we have getters for each of those. Pretty simple. You know, if we had properties in Java, this would be 5 lines of code. But we've got getters, but we can handle that. But now, let's say that we want to make this really easy to construct these objects, right? So we make a builder. Everyone loves builders. Well, here's a builder for this class. It just keeps going and going and going for this very simple class, right? So what I'm going to talk about today is a way that we can use some tools in the Java compilation process to write this code for us. And we're going to do that using annotation processing and code generation. All right? To start out, we're going to talk about annotation processing. So what is annotation processing? Well, annotation processing is part of Java-C, which is the Java compiler. This is something you generally don't have to deal with. Gradle takes care of this for us, or Maven, or Ant, whatever build tool you use. You know, Android Studio, you click the Run button, and it takes care of Java-C for you. With annotation processing, we read annotated sources. So I'm sure many of you have seen annotations before. They've got this @ symbol. And you can apply annotations to all sorts of different elements, which we'll talk about. And we can use annotation processing to generate Java source files. All right, so one of the key things to note here is that we can't modify existing code. All we can do is generate new code. There's some ways around that, which I'll talk about a little bit, but using the annotation processing frameworks, all you can do is generate new code. So let's see where this fits into our build lifecycle. So in the normal lifecycle of code, right, you write code, and these are Java files, so this is Java code that you're writing. You use Java-C or some other compiler to compile them into class files. And these are bytecode. This is what the JVM understands. And this is generally considered not very user-friendly, not human-readable. From there, we go into packaging. If it's a Java-only library, we might package a jar. For Android, there's a couple other steps. We have to dex, which converts our class files into dex files, and this is all optimized for the Android platform. And from there, we package into an APK, and this is what gets distributed. We're all pretty familiar with this. Annotation processing fits in right before that compile step. All right, so it's technically part of the compile step, but what it does is it generates Java files, not class files, but Java files that then get compiled just like all of the code that you wrote. There's a lot of advantages to this. This code, this generated code, is written by a program, right? So you only have to write that generator once. And that's really valuable. No matter how many classes you're generating, you only have to write it once. You can also trust that generated code. What you can do is you can just write tests for it, right? And then you know if it can compile or if it can generate appropriate source code, then you can generate 100,000 classes. They're all going to work. So that really allows you to trust this generated code. So let's move on to the components. So there's a few components of annotation processing. First, of course, are annotations. We need annotations in order to process the code. Next up is a processor. So that's pretty straightforward. And we're going to look a bit deeper into each of these. The next one I kind of referenced in the diagram before is the annotation processing tool. And this is actually the part of Java C that actually does the annotation processing. So this is sort of the engine of the annotation processor. And the last thing is annotated sources. So these are the sources that you write, that you annotate with, annotate methods and classes with the annotations. So let's start out by looking at annotations themselves. This isn't what they look like. All right, sorry about that. Going back, so let's start by looking at the annotations themselves. That's what they look like. So there are a lot of built-in annotations. You may have seen like inject is a JavaX annotation, so that's a Java extension annotation. Other things like override, right? IntelliJ or Android Studio keeps throwing all these overrides in. Well, what's the point? Well, nobody really knows. But those are annotations. So those are built-in annotations, which you're welcome to use. You can write an annotation processor that will process override annotations. That's perfectly valid. You can also create your own. In our case, we're going to generate that builder that we looked at before. So I want a new builder annotation. So what makes this an annotation? It looks like an interface, but we put the @ symbol in front of interface. And that's what turns this into an annotation. So this is an annotation type, just like classes, interfaces, enums. And then we have this retention annotation on our annotation. So this is an annotated annotation with the retention annotation. And this gives us the retention policy. And what that means is that there's a few different types of annotation, or use cases rather, for annotations. So there's runtime annotations, which if your tool uses reflection, it uses runtime annotations. And so you have a retention policy of runtime for that. In our case, we're generating code at compile time, and the retention policy basically tells Java how long these annotations need to exist. So with retention policy of source, that means that we need that annotation in our source code, in the Java file that we wrote, right? Once we get past that, we don't care about it. It's not going to be used at runtime. It's not going to be used in our class file. So you generally want to have the most limiting retention policy you can. That's going to be fun. With your choices being source, class, or runtime. Moving on from that, we have the target. And this tells you what you can place this annotation on. An override annotation, for instance, you can't put that on a field. You can't put it on a class. That's only valid on methods. And so these element type is an enum, which gives us all of the different types of the Java language. So type is a high-level type. And what that means is classes, interfaces, enums, any of those enclosing types, right? And then you have things like method, field, parameter. Those are all choices for the target. And you can have more than one target. So inject is a good example. That you can put on classes, methods, parameters, all sorts of stuff. So this is our entire builder annotation. What can we do about that? I wonder if I prop this guy up a little bit. Maybe that'll help. So anyway, so this is our builder annotation. And you can see this is how we're going to use it. All right? And I've actually got the class name wrong there. That should be user. But we put the builder annotation on our class. Because of the target, we tell it we're targeting a type. So that's how we know this is valid for a class. All right? And because of the retention policy, once this Java source file gets turned into a class file, this annotation will no longer be present, which is nice because it keeps your if you have a lot of annotations, it keeps your your code clean, your generated code clean, reduces load time, that sort of stuff. So let's move on to the annotation processor. All right, so this is the meat of what's actually going to be generating our code. So as you can see here, we have a foo processor which extends abstract processor. There's a processor interface, but you generally never use that directly. Abstract processor has some initialization stuff that it does for you. You can go look at the source if you're really curious. But basically, you're always going to use that. I guess the bottle cap didn't help. With our abstract processor, we need to make a no-arg public constructor. And I'll explain why in a little bit, but just know that there has to be a no-arg public constructor. And next up, we get this init method. And this is an abstract method on abstract processor. And basically, what this is going to do is no matter how many times this processor is run, how many classes it's processing, init is going to be called once. And what that allows us to do is get certain tools out of the processing environment. In this case, the messenger is a tool. This is how we give feedback back to the user. So this is how we send warnings, error messages. It's sort of like a logger, but it's a little different in that it sort of aggregates messages from the entire compile process. We also have the filer. This is how we're going to generate new files. So the filer is sort of our abstraction that knows where the build directory is, right? That's something you don't need to worry about, pathing on the file system and that kind of thing. So that's our init method. Moving on from that, there's a couple boilerplate methods that we have to implement in our processor. Get supported source version. This is where you can tell it you support, Java 8, Java 7, whatever that might be. This is sort of like the Target SDK version in Android. And just like the Target SDK version, generally you always want it to be the latest supported at compile time. Another method that we have is get supported annotation types. And this is where you tell the annotation processing tool that we talked about before what annotations you're going to process. All right, so what's going to happen is when the annotation processing tool starts feeding you annotated classes and objects, it's going to optimize to only send you the ones that you care about, and you do that by returning them in a set right here. All right, and then we get on to the important part, which is the process method. So in this case, we're going to get a set of all of the annotated types that the processing tool found. And then we have this round environment. Well, what is that? So let's take a look at the round environment. All right. In order to do that, we need to have a bit of an understanding of how the annotation processing tool works. So in this example, we have Java sources over here, all these blue boxes. These are Java sources that you wrote and annotated with different annotations, right? So during the annotation processing cycle, the first round for this code, when it first starts up, it's going to take those types, all right? And the annotation processing tool notices that these are annotated with some annotation that you care about, and so it passes them to your processor. Your processor processes them and generates some new files, right? So these have all been processed. So they move over into the completed pile. But now we have new sources, right? That the annotation processing tool hasn't had the chance to process yet. So that completes round one. Now we move into round two, all right? In which case, the annotation processing tool notices these new sources, which have been annotated, and sends them back to your annotation processor. It processes them, doesn't generate anything new, they move to completed, and now we are complete. We're done processing. So this is sort of meta. You can have an annotation processor that generates annotated source that it will then process as well, or maybe some other annotation processor will process. And these rounds just complete until there's no more sources to process. So The next piece we move into is this service loader discovery file. So service loader is an API introduced, I believe, in Java 1.5, and this is how you do extensions or plugins, that kind of thing. This is how the annotation processing tool determines which, let me just adjust this tape a little, see if that'll help. This is how the annotation processing tool determines what annotation processors are available at runtime. So basically what you do inside your jar file, you have a meta-inf services, and then this is the fully qualified name of whatever service you're implementing. All right, so in our case, it's a processor. And then in here, separated by new lines, you have all of the classes in this jar, fully qualified name, that implement that processor. And so what's going to happen is once Javac and the annotation processing tool figures out all of the dependencies for your project, right? And so everything that's on the class path, it's going to search for implementations of JavaX annotation processing processor. And so that's how it determines which processors are available. This is really powerful because what this means is that if you want to include an annotation processor in your code, something like Dagger, Butter Knife, Auto Value, anything like that, you don't actually have to write any code. All you have to do is have the annotation processor present in your dependencies, and it'll automatically be discovered. The way you do that is in your build.gradle file. So we have normal compile dependencies, right? These all get compiled into your final APK and included. So anything you include there counts towards your method count, towards the size of your final APK. Using either of these plugins, Android apt if you have an Android project, or the Gradle apt plugin for plain old Java projects. They add this apt annotation processing tool configuration. And what this allows you to do is a lot of times you'll see the annotations and runtime dependencies split from the processor itself. And the reason that you do that is anything in the annotation processing tool's configuration doesn't get included in your final APK, right? So processors, the processors that I've written use things like Guava, with all of its 20,000 methods, because I don't care. I don't have to, right? This isn't going to get included in your final dependency unless you accidentally add it to the compile configuration, right? But in this case, you can have, lots of dependencies. You're running on a development machine or a build server or something along those lines. So you don't generally have to worry about the performance issues and all that kind of stuff that you might otherwise if this is a runtime dependency on the device. All right, so that's enough about processors themselves. The second piece we have to talk about is the code generation itself, right? So we're making this annotation processor, and in the processor, you can do whatever you want, right? It's just Java. But what we specifically want to do is generate code so that we don't have to write it because we're lazy. So code generation pairs really well with annotation processors. We use it to generate new Java source files. Like I said before, you cannot modify existing source files because the dependency tree of files change of what has been processed, what hasn't, what has been compiled, gets really messy. So all you can do is generate new Java source files. And we're going to use Java Poet from Square, which is an open source library for code generation. And what it does really nicely is it represents Java sources as model objects, right? So we have models for all of the parts of Java. And here's a link down at the bottom, github.com/square/javapoet. So it gives you a really fluent interface. Look at me getting ahead of myself. So it uses a fluent API with builders to help you generate the code. And it's based on specs. A spec is basically model classes that are going to tell Java Poet
how to construct your Java code. So we have type specs, method specs, parameter specs, field specs. This may seem familiar. If you remember when we were looking at annotations, we told it the target. Well, these are all of the parts of Java, the language. All right, so types are classes, interfaces, enums, that sort of thing. Methods, we all know what methods and parameters and fields are. So Java Poet just helps you sort of describe how to write the code. So let's break up our user here, this user builder. This is what we're going to generate. I've cut out some of the extra pieces. So you can see I've basically broken this down into a single example of each type, right? We have our class, which is a type. You'll notice it's public final, for the modifiers on that. We have just one field, username. And then we have our username method, which has a return type, takes a parameter, has some statements in the middle. So this gives us a really good example of all of the different things we can do with Java Poet. So we're going to break this up a little bit. One of the things we need to look at first is this method returns a user builder, right? Our class is a user builder. So generally, I like to start from the outside and go in when I build these. So I'm going to generate that class first. But we need a way to represent, I apologize, I go from the inside out. But in this case, we need a way to represent that user builder when it hasn't been generated yet so that our method can return it. So what we do is we get the name. So in our case, the annotation processor, in this example, is a user builder. It could be a transaction builder. We don't know what it's going to be, right? It's anything that's been processed or annotated with the builder annotation. So in this case, what we're going to do, we're going to format a string. Whatever the type simple name is, user in this case, we're just going to add builder to it. So you could imagine this could be a builder, or it could be a building builder. Who knows? But that's somebody else's problem. What we use in Java Poet is class name, classname.get. And that returns this class name object, which is a way that we can represent class names. So we do that, we just give it a package and a builder in the builder name string, and that gives us something we can reference. So now that we have a way to reference it, we're going to move on to the inside, and we're going to start out with the field. Fields are pretty simple. What these things are made of are modifiers, private, final, static. All of those are modifiers. We have a type, and we have the name, right? Pretty straightforward. Java Poet basically lets us do all of this using a builder pattern as a field spec. We're making a field here, and you'll notice all of those elements are existing down there. We can add all of the modifiers that we want. We add the type and the name, and now we have a field spec which tells Java Poet how to write that field. All right, so now we have our fields. That's pretty easy. So moving on, methods. This is a little more complicated, but again, we have modifiers. So we have modifiers.
I'm sorry about this noise.
Yeah, apologize for all of the blackouts.
Sorry.
Just like fields, we have modifiers. We have a return type, all right? We have a name for the method. What we add on top of fields is parameters and then statements, basically 1 to n statements. So our method spec builder is a bit bigger, but we'll go through this one piece at a time. We have all our modifiers. In this case, it's just public, but you could have public static final, whatever you want. We have our return type, which in this case is the builder. And this is that builder type, that class name that we had generated before. We have parameters, sorry, the name, and then parameters, and then we just add our statements. And you can see this Fluent API makes it really easy. If this was a longer method, add statement, add statement, add statement until you're done. One of the things that I would like to point out is this notation right here. You'll see that first statement, we have this $n, right? So that, much like string formatting, that tells it to use the name of that username type. And so what that allows us to do is as we generate this code, right, we could just use string.format and write all of this code with string replacement and that, but it gets real hairy, really hard to keep track of what we've done, what we've named things. If we have to append numbers, for instance, to avoid collisions, how do we keep track of that? It can get really challenging. This username right here, this is the field that we created before, since we're referencing the field on this. So this basically allows us to use those objects that we've generated with whatever name they might have, and in this case we're referencing the name. It could be $T for the type, $L for literal. We have all of these formatting arguments that we can use there. So that's our method. And now going back to our user builder class, the last piece we have to make is the class itself. And the reason, even though I misspoke before, the reason that we work from the inside out is because in order to make the class, we need the body, right? Which means we need to have already generated the fields, methods, all of that sort of stuff. So looking at the class, in this case we have two modifiers, public final, we have a name, and then we have content, all right? So we're going to use a type spec here, and we're going to give it our modifiers, public final. I mentioned before, you can use as many as you want. We're giving it that builder type, that class name we generated early on. That's going to be the name of this class. And then we just give it its content. In this example, we only created one method and one field, but you can imagine in our final builder, we're going to have a bunch of fields and a bunch of methods to add to this. And that's it. At this point, this is still not code. This is just an object-oriented representation of how to build the code. So let's put that together with our annotation processor. We looked at the process method before, right? And so what we get are those annotations over there in the round environment. The annotations, if in our case, the only annotation we care about is builder. If you care about more than one type of annotation, this will tell you, in this round, these are the annotations that I found. And that just allows you to optimize so you're not trying to process annotations that don't exist. But anyway, on a round environment, we can get all of the elements annotated with our builder annotation. And we're going to step through each of those and do these 5 steps. We need to get the metadata for that element, so things like the class name, what properties it has, and that sort of thing. We need to create private fields and public setters. We need to create our build method, which is, when you call builder.build, the thing that actually assembles our user. We need to create the builder type, which is the class, and then we need to write that to a Java source file. So, we start with getting the element metadata. And this is sort of the code-heavy part. But we're just going to step through this. I've got a method there to get the package name out of the element type. You would think this would be easier since these are all represented as objects, but basically what you do is you just get the fully qualified package name and cut off after the last period. So that part's kind of barbaric. We get the target name, which we have to lower camel case the simple name of the type. And then we get all of the non-private variables. So this is one of the implications with this idea that we can only generate new source code, right? This source code isn't special. It doesn't have access to things that it wouldn't otherwise have access to. So in our case, we're sort of hamstrung here, so that this builder can only access the non-private variables. since it's not a subtype of our user class. So package private is fine because we're going to put it in the same package, or public variables. And then this is what we did before. We're just building the user builder, transaction builder. We're building that class name for whatever this type is. So next up, some more code that we'll step through. The fields and setters. So these are our methods and our fields. We need to add these to the class later. So when we generate them, we're going to collect them. So pretty simple there. We just have some array lists. And then for each variable, these are the non-private variables that we found before. We're going to step through each one of those and get the variable type so that we can get the name. And this is going to tell us on the builder what to make our method names and what to make the parameter names. We create the field on the builder. So the builder needs an internal field that it's going to set. And then we create our setters. All right. This is the same code that we just looked at moments ago. And you can see we're using the $n notation there for placeholders. And the $n is referring to this name that we created up here. We need to create the build method. This one we haven't looked at. And this one's a little different because these other methods, we knew the statements that were going to go in them. But the build method, we need to actually step through the fields and that we created before. So this one's a little more complicated. So what we're going to do is we sort of build the outside. And so we use a method spec builder, right? It's going to return our target type. It's going to be called build, and it's going to be public. And then we add our initialization statement. So this is an example of that placeholder notation, but just like in strings resources, you can make it positional. So in this case, we use the $1t versus $t, and that tells us the first argument or the second argument. So what this is going to do is do user equals new user, right? That's what we're going to generate there. And then we just step through each of those fields that we found before. So everything that you set on the builder with the first name method, for instance, we're going to actually set that on the user that we generated moments ago. So user.firstname equals this.firstname, right? This is pretty simple. And if you take a step back to look at the structure of your code, this becomes really simple. What I like to do when I'm doing this is I actually write out the target of what I want the generated code to look like, and then I just break it up into these little pieces. We add our return statement, and then we use that builder to build the actual method spec. Second to last is creating the builder. So this is the class, the user builder class. So basically, we just take all of those things we just generated, throw them in our public final class. Pretty straightforward. And then Java Poet has this Java file object. And this is how we create new Java files. So this is the builder that we just created. So we're going to make a new Java file, which, like a spec, this just tells Java Poet, what's included in this file. And then you tell it to write to the filer. And Java Poet's smart enough to know, based on the package name that we pass in, it can build out the structure so that it actually puts it in our build directory at the appropriate location. And one of the things that I haven't mentioned that Java Poet really helps out with is, if you notice, there's a lot of stuff that we kind of tend to forget about in our Java source files, specifically imports. I didn't write a single import line anywhere, right? I just told Java Poet the classes I'm going to use for the fields and the methods, and it takes care of adding all of the imports for us and organizing them, so we don't have to worry about that sort of thing, which is really great. So that's the last step, and again, a fair bit of code for these 5 steps. We do that for every element that's been annotated with our builder annotation, and the processor is done. You put it on the annotation processing tool configuration of the class path. If you're using If you're using Java C directly, I believe it's there's a command line flag for a separate class path for the annotation processing tool. And it's not going to get included in your APK. The generated code will. And here's how we use it. So we have our user before that we saw. I trimmed out the get methods because we all know those. Simply add the builder annotation to it. And then as soon as you build your project, you now have a generated builder class that gives you this very nice fluent interface to create your user objects. All right. One of the gotchas that confuses some people is I did mention here as soon as you build your project. This is a compile time thing. So you have to actually add the annotation and then compile your project in order for this code to be visible, right? You can write it before and when you before you compile, and then when you compile, it will exist by the time Java C sees it, so it'll be fine, but you won't get code completion and that sort of thing. So that's it. So some of the references, the Android apps plugin, don't put annotation processors in the compile configuration. You're going to get a whole lot of overhead that you don't want to deal with. Use the Android apt plugin. I believe if you're using Jack, Jack also has support for annotation processors. But Hugo Visser has made this great tool. The Gradle apt plugin, if it's a Java-only project, and then Java Poet. Those are the links there. These slides will be online, or you can see the video. If you want to get in touch with me, I'm on Twitter, rharter, or my website is ryanharter.com, and I'll be around the conference, so I hope to talk with you guys. Thank you.